gonna be clouds, I guess.
Okay. So we just set our agenda today. Right. First is check previous classes, and new topics, intro, and some problem solving. Okay? Solving and possibly summary. Okay? So just quick interview. Maybe like what did you do? So you had an exam, right, in this class? So pretty much like how do you rate your personal learning on the class? Like in that midterm, did you do well? Were you able to like at least have some idea where you like
Yeah, I need to understand the questions.
did you find it easy or like hard or like was it better than your first exam or first midterm?
Probably. I don't know.
You don't know?
I thought I did well, but then my friends, we talked about it after
Oh, the
the
answers.
semester, and then
Uh-huh.
we all
Compare.
messed up.
Really? Why?
We kind of messed up. Well, like the first one, my friend said it's 0, but then but we all got like the equation. But if you plug in the numbers, the equation will be 0.
Okay.
And I mean, the professor didn't say. The professor only wanted us to show the equation.
The equation.
will be equals 0, but
Yeah.
we didn't say it's 0.
Wait, that's good enough.
So we're probably gonna.
Yeah, like what kind of topics? What kind of topic was the exam?
There's Ampersol.
What?
Ampersol.
What is that?
Uh, the current and the magnetic field.
Okay. Oh, you mean the Ampere's law?
Oh, Ampere's law, yeah.
Ampere's law and Gauss law, right?
Yeah, I think they're together.
Gauss law, yeah, they're together. So.
And then the magnetic force.
Did you still remember Ampere's law?
No, I forgot everything.
Okay.
I feel depressed.
It's okay. So how about if you, for example, you have a wire and you pass a current through it, what's gonna happen?
There's E field and magnetic field.
Okay, magnetic field. Where is it?
It's around the
wire.
Yeah.
Okay. And what's the direction of it?
It's going outward.
Outward. And is it perpendicular to the current
Perpendicular to the
or
current.
parallel? Are you sure that it's perpendicular?
Yeah.
Are you sure?
Yeah.
Okay. So it's gonna be that like that, right?
Yeah.
Okay. So usually, well, maybe this way, right? Because your current is this way, so it's like your current. Oh, you were right. Okay, so this way. Is it doing this way, right? It's your current. And what do you call this? You use your hand for
Right hand rule.
Right hand rule. Okay. So right hand rule. Okay. So Gauss law, what does it say?
KQ over.
So for example, you have a magnet, you have a magnetic field, right? Or do you use the coil? Do you use the coil in the class? You talk about the coil?
Yeah.
You talk about the coil?
I think we did. I forgot.
So if you have like a coil, so a coil is usually like that, and then you put a metal next to the coil, you move this guy next to the coil, there's gonna be a voltage produced. Do you know that?
Yeah.
Are you sure? But this is like another way of looking at Gauss law. But usually when you make an example of Gauss law, you say that you have two magnets, there's magnetic field inside, and then there's a wire here, right? A wire with a current passing through it. the directions would be perpendicular to each other, right? So your current will be perpendicular to your magnetic field and to the force. So it's pretty much like three-dimensional. Do you think so?
Yeah.
What do you think? So like, okay, so this is my hand, right? And then this is my finger. So there's like another thing, right? Yeah. Is that? So this is your pointing finger. This is your another finger, and then this is your thumb. Okay. So where is the current?
Should we go
Going this way?
Yeah.
Where's the magnetic field?
I'll support.
Here? Okay. And then where is your force? Where's the force?
The thumb.
The thumb, right? Is that correct?
Yeah.
How do you make your convention?
F.
Yeah.
I.
B. Is that how you do it? Okay.
Yeah.
Okay. Makes sense. So, what is the principle? This is what to this. What is force to perpendicular? And okay. But you practiced. So before your exam, you practiced something about the cross product. Is that what happened? Is that what you had for exam?
I think it's the question I didn't do.
Oh, what? Why?
There's 3 actually.
Yeah,
on
you
the
did.
I
Okay.
didn't do on
Okay, the ones with the cross product. So like, you have the velocity and then the current. Is that what came
Yeah,
out?
I swatched remember.
Oh, you can't.
I did it like 2 weeks ago.
Oh yeah.
About this. That's true.
Okay. So, is it gonna be included in your finals though?
Yeah, I think everything will be in the finals.
Starting from the beginning.
Yeah. I'm not sure. I have to
So
double check.
maybe you need to check that out so that next week, when you come back, we can like talk about it more, like go a broad overview of everything.
Okay.
Maybe possibly like one example out of every case, and bring your exams as well. That would help. Okay. So now we'll do new topics. We'll be talking about so let's see. I have my notes here, but let's see this. Okay. So you're gonna talk about voltages, inductance, capacitance. Is that what he said too? Like in a circuit, that's gonna be what you're doing. So for example, so we will make a table now for voltage and then current, resistance, capacitance, and inductance. So what is this? What is it symbolize usually?
RB.
Okay, so R is usually drawn this way, right? And then C is drawn this way. L is drawn this way.
Oh,
Are you familiar with them?
We didn't do L yet.
You didn't do it.
We haven't do that
Yeah.
yet.
I'll give you an introduction.
Okay.
So that later, you can have like a sense of what's gonna happen. So that's resistance, capacitance, and then inductance. But I think you covered this one.
Yeah, we covered
This one too.
and not resistance.
And then this one's not yet.
No.
Yeah, not yet covered. So it's kind of new, but we'll focus on this too. So what's the voltage when you compute for the voltage in a resistor? How do you compute the voltage in a resistor? Across the resistor.
Cross resistance.
So for example, you have a resistor, and then what is this? So what is this? Like, in a loop, you have a voltage source, right? How do you compute for the voltage in this resistor, across the resistor?
Alright.
Okay. So what is it? That's Ohm's law, right?
Yeah.
Ohm's law is V V is equal to
IR.
Okay, IR. And then I is equal to what?
V over R.
Okay, over R. And okay. So what's the voltage across that resistor?
Should be I.
No, what's the voltage across this? So what is the voltage in this across this resistor? So you have a voltage source, and then you have a current underneath, right? What's the voltage of that resistor? Well, I mean, just a formula, you know.
Oh, IR.
IR, right? Okay. So it's IR. I'll say I times R. Okay. What's the current across the resistor?
V over R.
Okay. V over R. Okay. So for capacitance, what is the voltage across the capacitor? For example, you have this capacitor, you have a voltage source. What's the voltage across it?
It's C equals to delta V.
C equals to delta V. Okay. Delta V time over what? Q?
Yeah, Q.
Over Q. Okay. So how about if it's in a circuit though? What's the voltage across it?
V IR.
V equals still I'm sorry, but okay. I think this is due to you. I'm not sure, but have you heard of I is equal to C times dV over dt? Right? Have you heard of that?
No, but I understand that one.
Okay. So that is how you get the current across the resistor. For example, you have this loop and you have I. The current in this resistor, in this capacitor is equal to C times dV over dt. So it's a change of, so there's going to be accumulation of voltage in this one across as time goes by. Because what does capacitor do? It charges, right? If you put voltage across it, it's going to charge, and it's going to charge until it's full. When it's full, it's going to discharge, right? So usually, if you have this graph, you have 0 volts to 5 volts at time, but this is time though, so it's a function of time. So as time goes by, your capacitor is going to get charged, and then if it's fully charged, you can just right? So that's the voltage across it. Now to get the current in this thing, the formula is I equals C dV over dt. Okay? So capacitor times change in voltage. Okay? With second time. But if you get the voltage now, how would you do this? This is just mathematics. How do you get the V?
Do integrals?
Yeah. And what should I do? Integral
I dt equals C dV.
okay, I dt, correct? I dt equals C dV. Okay, then I'll get the integral.
Yeah, both integrals.
Okay. And so if I get the integral of this, what's gonna happen? What's gonna be left here? It's V, right? Or 1? Yeah, it's V, right? Because it's 1 dV. Or this is going to be C times 1 dV.
Yeah.
Right? So this is going to be V. And then this one is going to be, if I want to transfer C here, on this side, what should I do?
1
Like C, okay.
times T.
Integral of I of t is a function of time too. So you can say to I of t dt. So it's not a constant. It's not like gonna be the same or whatever. So it's gonna be 1/c integral of I of t dt equals your voltage. Okay? But you can start from here. Okay? That's your like major thing. And then so that's your voltage here, correct? So integral of so 1/c I of t dt. Your I of t is a function of time because it changes. Maybe it changes, maybe it doesn't. It's it's varying. It's changing. And so what's your current now?
I oh, C over dv dt.
C what?
dv dt.
Okay. Correct. Yeah. That's right.
Oh.
Okay. And also, so we came up with that. So that's our table. Maybe you can, you wanna like copy that or whatever for your reference. And then so I'm gonna give you a little bit of practice after this. So get a copy. Just a second. Let me show